This is a video about dot and cross diagrams. So what are dot and cross diagrams? Dot and cross diagrams are simply a straightforward way of drawing the electrons in the orbitals of atoms and compounds. Most of the time, we use dots to represent electrons in orbitals. You are probably familiar with diagrams like this, or even this, which show a nucleus surrounded by dot-like electrons. But electrons don't have to be drawn as dots or little circles. They could be drawn as little squares, little stars, little elephant silhouettes, or little crosses. We can draw an atom with electrons as crosses like this. This is a picture of chlorine. The full dot and cross diagram of chlorine shows that chlorine has 3 electron shells, with 2 electrons filling its first shell, 8 electrons filling its second shell, and 7 electrons filling its third shell. These outer electrons are known as valence electrons. These are the electrons that react. Atoms can bond as long as there is space in their outer shell to fit in more electrons. After this video, you may want to look at our video on bonding. Chlorine has space for only 1 electron to fill its outer shell. It now has the electronic configuration, the same number and arrangement of electrons, as argon, a noble gas, but it's charged because it has gained a negatively charged particle, the electron. We show this by putting square brackets around our ion and labelling the charge on the outside. Using a dot and cross diagram shows that the electron that is gained is in addition to the ones that belong to the chlorine atom. It is a visitor. We can draw the chlorine electrons with a cross and the guest electron as a dot. The chloride ion ends up with 7 cross electrons and 1 dot electron in its outer shell. Dot and cross diagrams provide a useful way to keep track of where electrons come from. Of course, we don't really know which electron is which. They all look the same. But this is a very useful notation for showing what has happened. Bonding occurs when an atom doesn't have the electrostatic force to steal another atom's electrons.